So if the sinusoidal axis is at 3, notice my midline is now at 3. I didn't put the x-axis, I just put 3. And if the amplitude is 1, that means the height from 3 plus 1 would give me the maximum, and 3 minus 1 would give me the minimum. So the domain of this, the domain is still all real numbers, but the range is from 2 to 4. This graph is going to go from 2 to 4 instead of negative 4 to 4. The graph, however, worked the same. It's still the same snake shape. There's still 4 quarter periods. It still goes all the way over to 360 degrees. And I just made 4 equal tick marks, 0 to 360, and then I marked my 4 quadrants. So let's take a look at this equation. This has both. It has a number here and a number here. That means the sinusoidal axis is the shift up or down, and we know that the shift up or down from every transformation we've done over the last few years has been that this has moved up 1. So the sinusoidal axis is at 1. The amplitude is the vertical stretch, that's this number right here, and that's 5. So if the midline is at 1, I'm going to draw this one while you're watching. If the midline is at 1, where is the maximum? It's 5 above the 1. So the maximum is at 6. And where is the minimum? It's 5 below 1. And so that's 1 minus 5. It would be at negative 4. So the range of this graph is negative 4 to 6. Another difference is this is a cosine curve. So it does not look like a snake. It has to look like a cup. So I'm going to make my 1, 2, 3, 4 tick marks. And I'm going to start up, middle, down, middle, up. Now I'm going to change this one up just a little bit. I want you to see this. What if I told you that this was not in degrees? What if I told you that this one is going to be in radians? Well, it doesn't go to 360 anymore. Instead, it goes to 2 pi, because 2 pi is the equivalent of 360 degrees. And what's the equivalent of 90 degrees? Pi over 2. So that would be pi over 2. This would be pi. This would be 3 pi over 2 and 2 pi. So we mark them the same way. It's just that my full period is 2 pi and my quarter period is pi over 2. It's just a little different. But what's the name of this point? 0, 6. What's the name of this point? Pi over 2, 1. What's the name of this point? 2 pi, comma, 6. And the last one has both again. Let's do this one in radians as well. So we're going to have our midline at negative 4, our amplitude at 7. Our graph is going to go from negative 11, which is below, 7 below that, all the way up to 3, which is 7 above. I draw my y-axis, and it's a sine curve again, so it's going to start at the middle, 1, 2, 3, 4 tick marks. Middle, high, middle, low, middle, and we draw our curve. And the only difference is this is at 2 pi, this is at pi over 2, this one is at pi, and this is at 3 pi over 2. How do I know that? Because the quarter period, it's 1/4 of 2 pi, so it's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Now, what if the graph has a horizontal translation? Notice the difference between these two equations. This equation right here is x plus 3, no parentheses. This is x minus 20 with parentheses. That is a shift. It is a phase shift, one direction or the other, side to side. Well, remember back when we had x minus c, and that really was a motion to the right? Well, it is here as well. This graph is going to go right 20 degrees. And so we're going to make our first mark right here at 20 degrees. It's to the right. Now we're still going to do 1, 2, 3, 4 tick marks. But it doesn't go from 20 to 360 anymore because it's still a 360 degree cycle. It's going to go from 20 to 380, which is 360 plus 20 to the right. And we're going to start our graph. It's at sine, so we're going to start it at our midline. We're going to draw our max. We're going to draw our min. And we go boom, boom, low, middle, and there's our graph. Okay, same thing. Where's this one going? Left 100 degrees. Now be careful, because if we go left 100 degrees and a quarter period is only 90 degrees, then we're going to really need, here's our left 100. We need one just to the left of the y-axis again, because that's actually still negative 10. But 1, 2, 3, 4. So we just try to make our tick marks evenly spaced. And this one isn't 360 anymore. It's 360 minus 100. So that's actually 260. It's a cosine curve. So here's my maximum. Put it up here at the top. Middle. Put this one down here at the bottom. Middle. Back at the top. And I have my cosine curve simply moving left 100. Now we call that, when we horizontally shift that, we call it the phase shift. Remember from our notes in the other section. It's called the phase shift. We're going to do more with that in the later section. These are the only two problems you'll have with phase shift in it today. I just wanted you to see how that works. The last change is when we squish the parent function horizontally. If we dilate it horizontally, it's going to change our period. Now the period so far has either been 360 or 2 pi, depending on if we were in degrees or in radians. But if we want to change that, we have to change our value of the equation. We have to change up the equation. So let's say I wanted to double my normal sine curve. I want to double 360. So let's double 360 and make it 720. Well, how do I write the equation? Well, the equation is it's counterintuitive. That means it's not the way we think it would go. We don't write y equals sine of 2x because this is a 2. Instead, we write the opposite of what we think. It's not times 2, it's divided by 2. So I would say 1/2 x. Just like here, we thought we were moving, it looks like you should be moving left, but you really move right. And here it looks like you should be moving right, but you're really moving left. Well, this one, instead of multiplying by 2, you're actually dividing by 2. And if I wanted my factor to be 1/4 as small, so I want to divide by 4, I want my scale factor to divide by 4, in the equation, it's going to be sine of 4x, because it's dividing by 4 for the dilation factor of 2, and then you do the reciprocal in the equation. All right, so let's put all these together. We have an equation, it's set up in this format. We have A right here in front multiplied. We have a B multiplied in the middle. You see my multiplied right here in the middle? We have a phase shift C, and we have a vertical shift D. D tells us the sinusoidal axis. Where is the sinusoidal axis located? At the center of the graph. A tells you the amplitude, means how tall it is. From that, you can find the max and the min. Okay? From that, you can find the max and the min. The C value is the phase shift. We'll work on more of that later. And the B value is called the period constant. It's not the period. The B value is not the period. Notice, this was the B value right here. This is the B value is 4, but the period was 90 degrees. The B value was 1/2, but the period was 720 degrees. So the period is not the same thing as the period constant, but we use it to find the period. And the way we do that is we'll either take 360 or 2 pi, whichever one we're working, and we will divide it by B. So 2 pi divided by B or 360 divided by B, whichever one you're working with.